Hello and welcome to this video on how to solve equations. Now before we get started, it's going to be important for us to understand the law of opposition, because we're going to be using the law of opposition in this lesson to help us solve equations. Now there's no better place to learn about the law of opposition than in 2 Nephi chapter 2. So I brought up a couple verses. Here Lehi is teaching his son Jacob about the law of opposites. Now let's take a look. He said, there must needs be that there is an opposition in all things. If not so, righteousness could not be brought to pass. Neither wickedness, neither holiness, nor misery, neither good nor bad. Wherefore, all things must needs be a compound in one. Wherefore, if it should be one body, it must needs remain as dead, having no life, neither death, nor corruption, nor incorruption, happiness, nor misery, neither sense, nor insensibility. Now, Lehi does a great job discussing some of the major opposites that exist in this life. Take a look. I see a bunch. So there's righteousness and wickedness. There's holiness. Opposite of holiness is misery. Opposite of good is bad. Opposite of life is death. Opposite of corruption is incorruption. Opposite of happiness is misery, and the opposite of sense is insensibility. Our world is built upon this idea that there's opposition in all things. Now that's important. In verse 14, it explains why. And now, my sons, I speak unto you these things for your profit and learning. If we understand how opposition works, we should be able to profit from it and learn from it. For there is a God, and he hath created all things, both the heavens and the earth, and all things that are in them, both things to act and things to be acted upon. So today we're going to use the law of opposition to solve equations, to act upon these equations, to find the desired result that we're looking for, the answer of the equation. So let's get started. So here are 4 equations that we need to solve. When we solve, we're trying to get the x value by itself. We want to get the x by itself because when the x is by itself, we'll know that that is the value that we were looking for. So let's take a look. Here we have x plus 7 equals 3. Now notice right now there is a plus 7 right here. Our goal will be to apply the law of opposites upon both sides of the equation to get the x by itself. Now we know that the opposite of plus 7, the opposite of addition, is subtraction. So to do the opposite of plus 7, we would minus 7 to both sides of the equation. We minus 7. Notice that we have a plus 7 and minus 7, so all that's left is x. And over here, we have a 3 minus 7. Well, that's negative 4. That's it. The cool thing about algebra is you can always plug that value back in. Negative 4 plus 7, well, that's 3. Perfect. Let's do the next one. Here, we have a 4x. Now, that means 4 times x. So again, I need to ask myself, well, what's the opposite of multiplication? Well, the opposite of multiplication is just division. So we'll use division to both sides of the equation to get the x by itself. So the opposite of times by 4 is divide by 4. We'll divide both sides by 4. Notice that when we do that, 4 divided by 4, well, that's just 1x. And you never have to write 1x. You just have to write x. A 1 times x, that's kind of redundant. We know that there's a 1 there. And 20 divided by 4 is 5. That's our answer. X equals 5. Now, most of these you probably could have done without applying the rules of the law of opposition. But if we can use the law of opposition, it'll help us to solve these harder ones that eventually we're going to get to. Let's take a look at this one. X minus 11 equals negative 3. I'm trying to get x by itself, and there's a minus 11 here. Yeah, I'm going to apply the law of opposition. Opposite of minus 11, well, that's plus 11. We add 11 to both sides of the equation. Here we're just left with x, because a negative 11 plus 11, well, that's just 0, equals negative 3 plus 11, well, that's 8. X equals 8. And you can plug it back in just to make sure. 8 minus 11, yep, that's negative 3. The last one, we have division. X divided by 6 equals negative 5. Ooh, what's the opposite of division? The opposite of division is multiplication. So the opposite of divide by 6 is times by 6. We'll times both sides of the equation by 6. That'll cancel these 6's out, leaving us with just x equals negative 5 times 6, which is negative 30. We use the law of opposites on both sides of the equation to get the variable, the unknown thing, this x value, by itself. So often in math, we're dealing with more complicated questions, not just ones that require one-step process like in the last problem. And so therefore, we're going to need to learn the 5 gots of solving. I call it the 5 gots because we're going to have problems that are a little more ugly, like this, 3x plus 5, open parenthesis, x minus 3, close parenthesis, plus 1/2 equals 3/2 plus 4x. Ooh, that problem right there, it's got a lot of parts to it. And so we need to have some kind of organization to solve these problems. So there's going to be 5 gots that you're going to want to always ask yourself. And you're going to want to always ask yourself these in order. Got number 1, you should ask yourselves, got parenthesis? So when you're looking at a problem, the first got you should always ask yourself is, do I got parenthesis in this problem? In this one we do. Notice we do. We have this parenthesis. And so if you've ever got parenthesis, you got to take care of that. And the way to take care of it is by using distribution. Distribution. You're going to have to distribute into the parenthesis to get rid of it. So on this problem here, I would distribute the 5 into the parenthesis. So I'd be left with 3x plus 5 times x is 5x. And 5 times negative 3 is minus 15. Plus 1/2 equals 3/2 plus 4x. So remember, the first got is got parenthesis. If you got parenthesis, you got to take care of it. And you're going to do it by distributing. The next thing you're going to want to ask yourself is, do you got fractions? Do you got fractions? If you've ever got fractions in a problem, you're not going to want to deal with those fractions. So the best way to get rid of fractions in a problem is to multiply everything by the common denominator. I'm going to write CD to abbreviate. CD means common denominator. So notice in this problem, I've got fractions. I've got a 2 in the denominator. I've got a 2 here and a 2 here, so I need to multiply everything by 2. So that's what I would do. I would times this 3x by 2 times by 2. This 5x times 2. This 15 times 2. This 1/2 times 2. The 3/2 times 2. And the 4x times 2. We're going to multiply everything by 2. When we do that, we're left with 6x plus 2 times 5x is 10x. Minus 2 times 15 is 30. Plus 2 times 1/2. You can use a calculator if you need to. I'm just going to do 2 times 1, which is 2, and divide it by 2, which is 1. Equals 2 times 3/2. I'm going to do 2 times 3. 2 times 3 is 6. And 6 divided by 2 is 3. Plus 2 times 4x, which is 8x. Notice that you multiply everything by the common denominator. I multiplied each of these terms by 2, and notice now I have no fractions. Yes! Problems without fractions are the best. That's why we multiply everything by the common denominator. Let's look at the next got. The next got number 3, is got lots of x's. Got lots of x's. Notice how in this problem, we have an x here, we have x over here. We have x's on the left and the right side. Whenever you got x's, and lots of them, you got to get them to the same side. That's going to be your goal. Same side and combine. We've got to get those x's to the same side. In this problem, I'm going to take all my x's to the left. It doesn't matter if you take them all to the left or all to the right. That's your preference. I think it's best to take them to the left. It seems like that keeps it the easiest. But if you're a person that likes the right more than the left, go for it. That's fine. So what I'm going to do is I'm going to minus 8x over here. Minus 8x to both sides. Notice how I'm doing it to both sides of the equation. Now when I do that, I've got to add up all my x's over here. So I got 6x plus 10x. That's 16x, but I have to minus 8x. So that's going to be 8x. I'm left with 8x I'm going to combine as well. So notice you got to do same side and combine. So I moved my 8x over here. I added all my x's up. I'm also going to combine my numbers. So negative 30 plus 1, that's negative 29 equals 3. Notice the 8x is gone from over here. So I used the law of opposition to move the plus 8x. I did minus 8x to both sides using the law of opposites. Sweet. The next got number 4. Got number 4 is got addition or subtraction. If you ever get to a problem and you've got addition or subtraction, you've got to take care of it by using the law of opposites. Law of opposites, just like we did in the last problem. So here, I'm going to undo my minus 29. To undo minus 29, I need to add 29 to both sides. Plus 29, plus 29. When I do that, I'm left with 8x equals 32. And now I'm just down to a one-step problem. I'm just down to this part here, which I'm going to call step number 5. The last step will always be got multiplication. Got multiply? If you've ever got multiply in your last step, well, we know how to do it. We're going to use the law of opposites again. So in this case, we're going to undo times by 8. To undo times by 8, we'll divide by 8. Divide by 8, divide by 8. And so my final answer comes out to be x equals 32 divided by 8 is 4. That's super cool. We use these 5 gots here to help us solve all problems in this class. Always start by asking, do I got parentheses? Then, do I got fractions? Then, do I got lots of x's? Then, do I got addition or subtraction? And then, very last, the last thing is got multiplication. That's how we solve these types of problems. To the boards! Welcome to the boards. It's time for you to take out a notebook or a piece of paper and give these 5 questions a try. Use the 5 gots that we've been talking about, follow them down in order, and work on solving for x. When you're done, you can check your answer by unpausing the video, and I'll go through and work them out with you. Good luck. Pause the video now. Okay, let's see how you did. Question number 1, I'm going to run down the 5 gots. Do we got parentheses? No. Do we got fractions? No. Do we got lots of x's? No, there's just one x. Do I got addition or subtraction? I do. I've got a minus 2. So I'm going to undo that using the law of opposites, plus 2 to both sides. That gets me 5x equals 40. Excellent. Got that one done. Got multiplication? I do. I have this 5x, 5 times x. So the undo times by 5, we divide by 5. And so the final answer there is x equals 8. Okay, good. Let's go to the next one. Again, going down the 5 gots. Got parentheses? No. Got fractions? No. Got lots of x's? Ooh, we do. We've got x's on the left and the right side. You could go to either side. You go to the left or to the right. I'm going to go ahead and go to the left. I don't know why. I'm just feeling like going. I'm left-handed, so I just always go to the left. But if you went to the right, that's fine. 3x minus 5x, that's negative 2x. Minus 2. Notice that the 5x's cancel out. I'm just left with 10. Okay, so I same-sided them, and I combined them. Good. Do we got addition or subtraction? You bet. We've got this minus 2. Opposite of minus 2 is plus 2. So we add 2 to both sides. That leaves us with negative 2x equals 12. And the last step is got multiplication. We do. We have this times by negative 2. Opposite of times by negative 2 is divide by negative 2. So I divide by negative 2. I get x equals negative 6. 12 divided by negative 2 is negative 6. That's our answer for number 2. Let's take a look at number 3 now. Number 3. I'm going down the 5 gots. Got parentheses? No. Got fractions? Yeah. Oh, fractions. Whenever you've got fractions, you got to multiply everything by the common denominator. Now, I've got a 3 in the denominator. I've got a 2 in the denominator, a 3 in the denominator. The common denominator of this will be 6. You could have also used 18. There's lots of common denominators, but if you can pick the least common denominator, that kind of helps. I'm going to multiply everything by 6. So I'm timesing this by 6, and this by 6, and this by 6, and the x by 6. Don't forget, you're going to multiply all the terms by 6. There's 4 terms here. We multiply each term by 6. Now I'm going to do some math here. 6 times 2 is 12. 12 divided by 3 is 4x. Here we've got 6 times 1. That's 6. 6 divided by 2 is 3. Here I've got 6 times 1. That's 6. 6 divided by 3 is 2. And then 6 times x is 6x. Cool. Notice that all the fractions are gone. Next step, got lots of x's. I do. I've got x's over here and over here. Again, I'm just going to go to the left. Minus 6x, minus 6x. If you went to the right, that's fine. You should get the same answer as me. That's negative 2x plus 3 equals 2. As we move the negative, as we subtracted 6 to both sides. Got addition or subtraction? We do. We've got a plus 3. Opposite of plus 3 is minus 3, so we do that to both sides. That leaves me, wow, that's a bad line there. That leaves me with negative 2x equals negative 1. And so in my last step, I've got multiplication. I do have a times by negative 2. So I'm going to divide both sides by negative 2. Divide by negative 2. So my final answer comes out to be negative 1 divided by negative 2. A negative divided by a negative is going to be positive. So my answer is x equals 1/2. We're rocking it. Let's keep going here. Question number 4. Again, going down the parenthesis. Do we got, going down the 5 gots. Do we got parenthesis? I do. So I need to distribute into the parenthesis. I take the 4 in, and I get 4x plus 4 equals 3. And here we've got to take in the negative 2. Now, don't forget to distribute the negative 2. It's going to be minus 2x plus 6, because it's the negative 2 that we're taking in. Okay, good. Got fractions? No, don't have to worry about it. Got lots of x's? Yeah, I got x's on the left and the right. I'm going to move them all to the left. Plus 2x. Plus 2x. That leaves me with 6x plus 4 equals 3 plus 6. I'm going to go ahead and combine these. 3 plus 6 is 9. Do we got addition or subtraction? Yep. Got a plus 4. So I minus 4 to both sides. That leaves me with 6x equals 9 minus 4 is 5. Got multiplication? Yep. We got this times by 6. To undo times by 6, we are going to divide by 6. Divide by 6, divide by 6, and that's our final answer. X equals 5/6. And the last question, question number 5. Here we go. I'm going down the 5 gots. Do we got parenthesis? No. Do we got fractions? Yes. Ooh, I've got a 5 and a 7 in the denominator. I got to multiply both sides, all sides, multiply everything by 35. Okay. I'm going to multiply this by 35. I'm going to use a parenthesis here just so I remember. And this by 35. Now, you could actually cross-cancel before you actually do this. 35 divided by 5 is actually 7. Does that make sense? I'm taking 35 divided by 5, that's 7, and then I've still got this 2x plus 1. I'm going to do the same thing on this side. I've got 35. 35 divided by 7 is 5. And then still inside, I've got this 3x plus 2. That's probably the best way to do it, is divide those first, and then whatever's left over, put outside the parenthesis. Now I've got parenthesis, so I should probably go back and distribute into the parenthesis. 14x plus 7 equals 15x plus 10. Okay, so we took care of the fractions and the parenthesis. We got lots of x's? Yes. I'm going to go ahead. You know what? Just for those of you out there, I know there's some people that want me to go to the right, so I'm going to do it. I'm going to the right here. Minus 14x, minus 14x. I'm left with 7 equals 15x minus 14x. Well, that's just x plus 10. Do I got addition and subtraction? You bet. I got this plus 10. So I'm going to minus 10 to both sides. Minus 10. And so my final answer comes out to be x equals negative 3. X equals negative 3. I didn't have to do the last step. There was no multiplication at the end. So x equals negative 3 is our final answer. There are some situations when you're solving equations where something really strange can happen. And I want to show you this to make sure everybody's aware of this particular situation. Let's pretend I was solving this problem here. 5x plus 3, open parenthesis, x minus 2, close parenthesis, equals 8x plus 10. As I work on my 5 gots, I've got parenthesis, so I take the 3 into the parenthesis here. I get 5x plus 3x minus 6 equals 8x plus 10. I don't have any fractions, so I don't have to worry about that. Do I got lots of x's? I do, so I need the same side and combine them. So 5x plus 3x, I'm going to combine it really quick. 5x and 3x is 8x minus 6 equals 8x plus 10. So now I'm going to get the 8x's to the same side. I'm going to go ahead and minus 8x. I'm going to move them all to the left. But something really strange happens. I call it a WJH moment. WJH, the what just happened moment. Take a look. As I do 8x minus 8x, the x's are gone, and all I'm left with is a minus 6. And over here I get 8x minus 8x. Oh no. The x's are gone there as well. And I'm just left with 10. Now this is strange. Does everybody see what just happened? All the x's just canceled themselves out. And I'm left with negative 6 equals 10. So what do I do now? This is a good what just happened moment. Whenever this happens and you're solving equations, one of two possible things can happen. So if the x's cancel out and you're left with a false statement, that's what's happening here. We're left with a false statement because negative 6 obviously does not equal 10. And if that's the case, you're going to say the answer is no soul. Oh, that's the wrong kind of soul. Hold on. That's this kind of soul. Soul man! Okay, wrong kind of soul. Not no soul, but no solution. No solution. When it's a false statement, you're going to say the answer is no solution. If it came out as a true statement, like if it said negative 6 equals negative 6, if it ends up as a true statement, then we would say that our answer is all real numbers. That means that you could plug any number into it and it would be true. But for this problem here, we would say the answer is no soul. And that's the solution to that. Let's have you try a couple. To the boards! And now it's your turn. Go ahead and pause the video and try number 6 and number 7 here on your video notebook. Give these a try. When you're ready to check your answer, you can unpause. Be looking for those what just happened moments. It might happen on these two problems. Good luck. Welcome back. Let's get started here. We're going to go ahead and follow the 5 gots like we have been doing with all these problems. I'll work on number 6 first. We got to deal with the parenthesis. Do we got parenthesis? Oh yeah, it's right here. So we're going to distribute the 3 into the parenthesis. We're left with 2x plus 5x plus 3. And when I distribute the 3, I get 3x plus 3 plus 4x. Okay. What's next? Got fractions. In this problem, we don't got fractions. We don't have to worry about that. Got lots of x's. We do. So same side and combine. You know, because I have so many x's, I'm going to combine them first. It doesn't matter what order you do. I'm going to go ahead and combine first. So 2x plus 5x is 7x. And over here we have 3x and 4x. That's 7x plus 3. Okay, so I combine. Now I'm going to go ahead and get them on the same side. Minus 7x to both sides. I'm going to move them all here to the left. But notice when I do that, 7x minus 7x, that's gone. And here 7x minus 7x is gone. And I'm just left with 3. Uh-oh! That's the what just happened moment. The x's canceled out, leaving me with no more x's. All I have left is 3 equals 3, which is a true statement. And because it's a true statement, my answer is going to be all real numbers. That's going to be my answer for this problem. Okay, let's take a look at number 7. Again, we're going to go through our 5 gots. Do we got parenthesis? We do. So I'm going to distribute the 2 into the parenthesis here. Let's see, that's going to be 2/3 x. And then I'm going to distribute the 2 here. So 2 times 5 is 10, divided by 2 is just 5. Okay. And over here I have 2/3 x plus 1. Good. Got rid of the parenthesis. Now I've got fractions. Ooh, I do got fractions in this one. So I need to multiply everything by the common denominator. We've got a 3 in the denominator, a 3 in the denominator. So therefore, I'm going to multiply everything by 3. This by 3, this by 3, this by 3, and this by 3. Let's see. 3 times 2 is 6. 6 divided by 3 is 2x. 3 times 1 is just 3. Here, 3 times 2 is 6 divided by 3 is 2x. And here, 3 times 5 is 15. Okay, good. Do we got lots of x's? Yeah, I've got some x's on the left and the right. I'm going to get them to the same side. So minus 2x, minus 2x. Oh no, look what happens again. The x's go away. X's cancel out here, leaving me with just 3. Here, the x's cancel out, leaving me with just 15. Ooh. So when the x's go away and I have a false statement, this is false. And so therefore, because it's false, my answer is no solution. No solution. No soul. Nice work. Welcome back. Nice work at the boards. We're now moving on to the next topic, which is about solving formulas. Sometimes it's possible that we'll have a formula that we'll want to solve for a different variable. I don't know. Here, let's take a look at the perimeter formula of a rectangle. Perimeter of a rectangle equals 2 times the length plus 2 times the w, the width. Now, this is a great formula for finding perimeter of a rectangle, but sometimes it might not be what we're looking for. Maybe we don't want to figure out what P is. Maybe we want to figure out what W is. I sometimes call these types of problems the Free Willy problems. I don't know if you've ever seen that movie, but you know, they're trying to free the whale. Well, sometimes we might want to free a different variable. Right now, P is free. P is all by itself, but we might want to free something else. This W, the Willy. And so to do that, we can also use the 5 gots to solve formulas. All you got to do is go down the same 5 got process to get W by itself. Let's try it. I'm trying to get W by itself. Let's look. Got parenthesis? No. Got fractions? No. Got lots of, now in this case, it's not X's, it's W's. Do we got lots of W's? No. Do we got addition or subtraction? We do. We have a plus 2L. So I want to undo plus 2L. Well, I would have to minus 2L to both sides. Minus 2L, minus 2L. In doing that, I'm going to have P minus 2L equals 2W. Now, Willy is still not free. We still got some work to do. Let's go to the next got. Got multiplication. We do. We have this times by 2. So to undo times by 2, we're going to divide by 2. And we'll divide all this by 2. And so we get W equals P minus 2L all over 2. That's our answer. You could go further if you wanted to. Some people look at that and they're like, ooh, I think I could divide by 2. You could actually divide both the top values by 2. So it would be P over 2 minus 2L over 2. And that would allow you to cancel the 2's so that the answer would be P over 2 minus L. Both these answers are fine. This is written as a single fraction. And this right here is written as a simplified, but it's 2 fractions. So both of those answers are fine. That is how we solve formulas. We can use the 5 gots to solve formulas. Let's have you guys give a couple a try. Let's go to the boards. It's time for you to try question number 8 and 9. In number 8, you've got to free the M. Get the M by itself. And in question number 9, you're going to need to get the B by itself. Free Billy. Go ahead and pause the video now and see if you can't get these variables by themselves using this 5 got process. Good luck. Okay, welcome back. Let's take a look at how to solve these problems. We got to get M by itself, so I'm just going to go down the process here. Do we got parenthesis? No. Got fractions? No. Got lots of X's. In this case, we're solving for M. Do we got lots of M's? No. Got addition or subtraction? Yeah, we've got this minus 8z. So to get rid of that, we're going to add 8z to both sides. Perfect. So I'm left over here with just 2m equals 10 plus 8z. Cool. The last step got multiplication. Yeah, we got this times by 2. So I'm going to divide by 2. Divide all this by 2 here. And when I do that, I get m equals, let's see, 10 divided by 2 is 5. And 8 divided by 2 is 4z. And so now, notice we have m by itself. And so now we know m equals 5 plus 4z. Question number 9. I'm going to do a different color here. We got to solve for b. So let's go down my 5 got process. Parenthesis, no. Fractions, yes. Uh-oh. We've got a 1/2 here. Anytime we've got fractions, we need to multiply everything by the common denominator. So I'm going to multiply this by 2 and this by 2. We're multiplying everything by 2, each term by 2. So when we do that, we're left with 2a. Here, the 2 times 1/2, that just cancels out. And so we're left with bh. Do we got lots of, we're solving for b. Got lots of b's? Nope, just one b. Got addition or subtraction? Nope, don't see any. Got multiplication? Yeah, I've got this times by h. So to get rid of times by h, we're going to divide by h to both sides. And so that's going to be my answer. 2a over h equals, notice the h's cancel out, and b is now by itself. We freed the b. Perfect. Just to let you know, I see a lot of students sometimes mess this up. They think when it says multiply everything by 2, they have to multiply this by 2, this by 2, and this by 2. That's not true. You only multiply each term by 2. So if I had, like, I don't know, 3x plus y plus z. If I was going to multiply everything by 2, I would multiply this by 2, this by 2, and this by 2. But notice that I'm not going to multiply all of these by 2 because they're not separated with plus signs. This entire thing is one term, so we only multiply each term by 2, every term by 2. Excellent. Nice work with those. In summary, we learned in this video how to solve equations using the 5 GOTS. We also talked about those what just happened moments when you end up with the variable canceling out. In that case, you might get the answer being all real numbers if you're left with a true statement, or no solution if you're left with a false statement. We also learned that you can solve formulas using these same 5 GOTS. Well, thanks for watching. Keep up the good work.